Okay, students, let's look at the question that I given you in the previous class. That is, we were having a conducting wire. What I told you was this conducting wire was cut into two equal halves. Then one half was pulled in such a way, it was pulled in such a way so that its length is doubled. Its length is doubled. Then what is the final resistance if the initial resistance is R? If the initial resistance is R, let me call the final resistance as R dash. You are asked to find out the final resistance. Let's say if the length of this wire is L and the area of cross section of this wire is A. If it is cut into two equal halves, obviously this length will be L by 2 and the area of cross section remains A itself. Let's say R is equal to rho L by A. This is the basic expression. Therefore, we could use R is equal to rho L by A in this equation. And in this case, if I am saying it as R1, then R1 should be rho L by 2 divided by A. Okay. Then let's look at this diagram. If L by 2 length wire is doubled means its length will become L. This wire is pulled and its length is doubled. Therefore, this L by 2 length wire, if it is doubled by pulling it, it will become L. Okay. Then we have learned in our previous class, if length is doubled, area will be halved. Therefore, this area of cross section will be A by 2. You can refer the previous question. If the length of the conductor is doubled, since the volume is not changing, the area of cross section will be halved. Okay. Therefore, R dash, for R dash, we could write R dash is equal to rho L divided by A by 2. By 2 will go to numerator, 2 rho L by A. And can you say who is rho L by A? Rho L by A was our R. Therefore, it is 2R. Then the answer is the final resistance is equal to 2 times R. Okay. Hope you have understood this. Okay, students, now let's speak about the combination of resistors. Now let's speak about the combination of resistors. For that, if I am drawing a circuit diagram like this, imagine we are having a circuit diagram like this. These are three resistors which are connected in series, and let's call the resistance of the three resistors as R1, R2 and R3. R1, R2, R3 are the three resistors. It's connected to a V volt battery, and if it is connected to a V volt battery, there will be a current flowing in this direction. Let's say the current is I, and this I current, it will flow through R1, R2 and R3. That means the current flowing through R1 is equal to current flowing through R2, and that's equal to the current flowing through R3. In series combination, current is same. In series combination, current is same. Bear in mind. Then this resistor, the first resistors, these two terminal will have a potential difference, and let's call that potential difference as V1. The second resistor, these two terminals, the second resistors opposite terminals will experience a potential difference, and let's call that potential difference as V2. And the third resistors, two terminal, will experience a potential difference of V3. That means potential difference are not same. Then we could say the total potential V is equal to V1 plus V2 plus V3. If we are considering this circuit, the total potential can be taken as V1 plus V2 plus V3. It can be taken as V1 plus V2 plus V3. Then the total potential is V is equal to V1 plus V2 plus V3. That means we could write by Ohm's law. We know by Ohm's law V is equal to IR. V is equal to IR is our basic expression for Ohm's law. Then what can we write about V1? V1 is the potential difference across the first resistor. It could be written as IR1 since current is same. Similarly, V2 can be written as IR2 and V3 can be written as IR3. You can see it from the diagram. Then if we are substituting for V, we could substitute IR is equal to V1 can be substituted as IR1, V2 can be substituted as IR2, V3 can be substituted as IR3. What can we take common out? IR1 plus IR2 plus IR3, I is taken common out. Then we could write R1 plus R2 plus R3. Hope you are following this. Then we could cancel this I and I. We'll get R is equal to R1 plus R2 plus R3. And what's this combination? This is series combination. Therefore, I could write Rs is equal to R1 plus R2 plus R3. This is the expression that we have to remember for series combination of resistor. You might have learned in your smaller classes also. Then Rs is equal to R1 plus R2 plus R3. And you should remember this expression also. This is also an important expression. That is, in series combination, the total potential of the battery will be sum of the potential difference across the each resistors. Okay. Therefore, we are having two equations, and you should remember in series combination current is same. Okay, the total current is equal to the current across each resistor. Okay, then let's go for a special case, that is if there is n number of resistors. If we are having n such resistors, then we will have to say Rs is equal to R1 plus R2 plus etc plus Rn. Okay, therefore this is the case of n such resistors. If we are having n such resistors, then we will have to write Rs is equal to R1 plus R2 plus etc up to Rn. Okay, then let's say another special case, that is if there is n identical resistors. That means all the resistors are of same resistance. If there is n such resistors, then we will have to say Rs is equal to R plus R plus R up to n times. R plus R plus R up to n times means it is NR. Okay, this is the formula that we can use if there is n identical resistors. If there is n identical resistors, we could use Rs is equal to NR. Okay, then let's say if there is n identical resistors, like this, and each resistors are of R, then let's say the potential difference across each resistor, let me call it as V dash. Therefore, the potential difference across the second resistor is also V dash, like this, V dash. Then we could write this expression as, if there is n identical resistors, then this expression can be written as total potential V is equal to n times V dash, and V dash is equal to V by n. What is V dash? V dash is the potential difference across any one resistor. Okay. Therefore, this is regarding series combination. Hope you have understood this. Now we can speak about parallel combination of resistors. For speaking about parallel combination of resistors, let's have a circuit diagram which is having three resistors connected in parallel to a V-volt battery like this. Okay. Then let's say the resistance of each resistor are R1, R2 and R3. Then since it is in a closed circuit, there will be a current flowing. Let's say an I current is flowing through the wire, and if the I current is reaching over here, it will have to branch into the three wires. Therefore it will branch as I1, I2 and I3. Therefore the current flowing through first resistor, that is R1, is I1, flowing through second resistor is I2, and third resistor is I3, and it will combine and form I1 plus I2 plus I3, that is I itself, and it will complete the circuit. Okay, then you just analyze the potential difference. If you are analyzing the potential difference across these two terminals, it will be equal to the potential difference across these two terminals. Why? It's because there is no additional resistor that it has to bypass. Therefore, the potential difference across R1 should be equal to potential difference across these two terminals. That means the potential difference across the battery. Therefore, the potential difference across R1 will be V. Similarly, the potential difference across R2, it should be the potential difference across these two terminals, and that should be equal to the potential difference across these two terminals. That means the potential difference across R2 is also V. In the similar manner, we could say the potential difference across R3 should be also equal to V. That means in parallel combination, voltage is same. You could see in series combination, it was current that was becoming same. But in parallel combination, the voltage is same. Voltage is same. Then we could write the relation, that is total current I is equal to I1 plus I2 plus I3. We could write total current I is equal to I1 plus I2 plus I3. And since I is equal to I1 plus I2 plus I3 is the relation over here, we will have to use Ohm's law. That is, we know Ohm's law, V is equal to IR. That is, V is equal to IR. Therefore, I is equal to V by R. According to Ohm's law, we could write I is equal to V by R. That means, what's I1? I1 should be equal to what potential difference across R1 divided by R1, that is V by R1. Similarly, I2 should be equal to V by R2, and I3 should be equal to V by R3. Clear? We could write I1 is equal to V by R1, I2 is equal to V by R2, and I3 is equal to V by R3. Then let's substitute. Let's substitute for I. In this case, we will get V by R is equal to V by R1 plus V by R2 plus V by R3. That means V by R1 plus V by R2 plus V by R3. We could take V common out of this equation, and we could write 1 by R1 plus 1 by R2 plus 1 by R3. Okay, then we are getting a relation like this. Then from this relation, we could cancel this V and V out. Then ultimately we are going to get an equation of 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Then what is this combination? This combination is parallel combination. Therefore, we could write RS is equal to 1 by R1, 1 by RS is equal to 1 by R1 plus 1 by R2 plus 1 by R3, and you will have to remember this equation. This is one of the important equation in the what? In the parallel combination, and you will have to remember this equation also. That is, in parallel combination, the total current is equal to the current across the sum of the current across the each resistor. Okay, then let's go for some special case. That is, if there is n resistors, connected in parallel, then we will have to write 1 by Rp is equal to, it's not Rs, I have written it accidentally, it was Rp. 1 by Rp is equal to 1 by R1 plus 1 by R2 plus etc. Finally 1 by R, and this is the resistance, or this is the relation for resistance we can use for n resistors connected in parallel. Okay, then let's go for another special case. If there is n identical resistors, that means all the resistance values are same, then the formula will become 1 by Rp is equal to 1 by R plus 1 by R plus etc. up to 1 by R. That means we could write 1 by rp. We could write 1 by rp is equal to n times 1 by